All right, guys, I'm going to go through the review. And remember, you're going to have a summative assessment on Friday covering this material, okay? So just really focus. Let's start off with number one. Now, number one is an exponential equation, and we know that because, see that little x? The x is an exponent. Biggest thing is, you see this 4? He doesn't do anything. Like, he doesn't do anything to the graph. He is actually the base of the exponent. So don't look at him, okay? So let's start with the 8. The 8 is a vertical, it's a stretch of 8. I'm going to put it up here. Vertical stretch of 8. Okay, and then the 5 is down 5. Now, when you look at both of these have to do with the y-coordinate. So what we're going to do is we're going to multiply the y-coordinate by 8, and then we're going to subtract that by 5. Now, with the exponential equation, he has his own parent function. So his parent function, I'm going to put it right here. Your x's, -1, 0, 1. Your y's is 1 over b, 1, and b. Okay, so you need to know what your parent function is. Now, b stands for the base. So this is the only time this 4 comes into play. Okay, so this 4 is the base of your exponent. So wherever we see a b, we're going to put in that 4. So let's get our parent going. So we'll have -1 and 1/4. We'll have 0 and 1. And we'll have 1 and 4. Okay, so now we do the stuff to it. So the first thing I'm going to do is the vertical stretch, and that means I'm going to multiply all the y's by 8. So 1/4 times 8 is 2. 1 times 8 is 8. And 4 times 8 is 32. Nothing happens to your x's, nothing at all. And I'm going to check off my vertical stretch because I just did it. With the down 5, what I'm going to do is, again, that's your y-coordinate. You're going to subtract off 5 from all your y's. So 2 minus 5 is -3. 8 minus 5 is 3. And 32 minus 5 is 27. Again, I'm going to check off my down 5 because I just did it. Those are the points that we will plot on our graph. Okay, so biggest number here is 27. So we need to count by something different on our y's. So let's see, 3, 6, 9, that's not enough. If I do 5s, or what if I do 4, 8, 12, 16, let's just do 5s. And then I'm going to go ahead and graph. So -1, -3. 0, 3. And 1, 27. So 5, 10, 15, 20, 25, 27. Now, here's the dots. And at any point in time, you're like, what's kind of happening? What is my exponential equation approaching? So if I go to my graph, go to my y equals, I'm going to put that in my y equals. So 8 times 4 to the x minus 5. If I go second table, you should be able to see what your graph is approaching. So see how it kind of gets closer and closer and closer to -5? Okay, so closer and closer and closer to -5. So -5 is going to be your asymptote. Okay, so closer and closer and closer. So you can always check, if you don't know, who your graph is approaching. So again, I'm going to draw my little swoop. Again, I just figured out that my asymptote is -5. So it's going to approach -5, but it's never going to touch it. Okay, that's what asymptote means. And then remember, your asymptote and your range are very closely related, except your range is in an inequality. So when you look at -5 right here, remember we counted by 5, so this is my -5. Now, everything is above it, so we want to say y is greater than -5. Now, we don't put the little line under it because it's never going to touch -5. So it's just greater than -5. It's not greater than or equal to because it's not going to touch it. Over here, your domain is always all reals. And your y-intercept is where it touches the y-axis. You can look at your chart if you want. It's touching the y-axis at 0, 3. And that's it. All right, let's try another one. Now this one is, see how this one's a little bit different? It's got an E. See that E? That means he's got a different parent function, but before I go and put the new parent function, I'm going to tell you what's happening up here. So the -4 is going to be right 4, and the +1 is going to be up 1. Okay, I'm going to get my parent function. And again, remember it's different. The parent function for this one is -1.4, 0, 1, and 1, 2.7. So this is your parent function. This is where you start when you're doing an E, okay? Then all we got to do is what we're supposed to do. So it says right 4, that is the x-coordinate, and right is plus. And up 1, that is the y-coordinate, and that's just +1. So I can do them kind of at the same time. So let me write a new little t-chart. So all the x's, I'm going to do a +4 to. So -1 + 4, 0 + 4, and 1 + 4. Okay, so there's my x's. Now I'm going to do an up 1 on all my y's, and all I got to do is add 1. So 0.4 + 1, 1 + 1, and 2.7 + 1. All right, so I don't have any huge numbers, so I don't have to count by anything different. I'm just going to come over here, and I'm going to put some dots. So over 3, up 1.4, over 4, up 2, and over 5, up 3. All right, so there's my dots, but let's come over here. I'm going to put my calculator over here. Let's go to our y, and I'm going to put E. Okay, and then it's x - 4 up there. And then we have +1. Okay, so again, all I did was just put it in my calculator. I'm going to go second table. So, look at this. Just approaching 1, approaching 1, approaching 1. See how the 1s are all over there? Approaching 1. Uh-oh, I think my calculator just died. So again, it's just approaching 1 the whole time. And if I look at the graph, see, look at the graph. It's still a swoop, and it's approaching 1 the whole time. So let me swoop it over. So if at any point you're confused about what the graph looks like, you know, you have your calculator. Put it in your y equals and see what's up, okay? So my asymptote, it's approaching 1, it's approaching 1, it's approaching 1. So I know my asymptote is going to be y = 1. Remember, your asymptote and your range very closely related, except for 1 has an inequality. So let's look at our range up here. Here's 1. The graph is above the 1, so we know it's going to be y is greater than 1. Okay, for my domain, again, it's all reals. And then for your asymptote, or I'm sorry, your y-intercept. So that is going to be where, if you go second trace, for your value is going to be 0. So look, it's going to be approaching 1. So 0, I'm just going to probably say 0, 1. All right, so there he is. What do we think about that? Okay, so again, there's going to be graphs on there that have different parent functions. So let's look at them one more time and see how we can figure out the difference. See how this one doesn't have an E added at all? No E. Okay, that is this guy. This is the parent function for that one. The one that does have an E, this is your parent function. Okay, so they have different parent functions. You have to be able to recognize that. Now, next thing we learned was all these formulas. So now let's look at the formulas. So I have my growth and decay right here. I went ahead and wrote out some stuff so you can remember. Remember the A on both of them is your initial amount. The R is your rate. Remember, we write the rate as a decimal, so we end up moving our decimal place over twice. So same over here, decimal rate. And then T is our time. Okay, so that's for exponential growth and exponential decay. Now let's cruise over here. Now I wrote some stuff down over here because I wanted to make sure that you knew what N meant. When we do compound interest, your P is still your initial amount, your R is still your rate, but the N is what's causing people some issues. Your N is your number of compoundings in any 1 year. And what they'll do for N is they'll use these words down here. So like if it says yearly, then your N is going to be 1. If it says semi-annually, your N is going to be 2. Quarterly is 4. Monthly, 12. Weekly, 52. And daily, 365. These all have to do within a year. Okay, so 4 times a year. There's 12 months in a year. There's 52 weeks in a year. There's 365 days in a year. So these will be the type of things that you'll get for N. Okay, so N goes here on the bottom and ends up here on the exponent, and your T is just your time in years. So again, maybe copy this down, maybe kind of know this, because the N is probably the trickiest part. So let's start with number 3. So number 3 says, what is the decay factor? Now, your decay factor, let's look up here. Your decay factor is what is in the parentheses. So this 1 plus R is the decay factor. Well, it's the growth factor, okay? This 1 minus R, that is the decay factor. So when you're looking down here at the equation, what's ever in the parentheses is your decay or growth factor. So this one is going to be our 0.8. Okay, so it's just asking you to identify what it is. All right, let's try number 4. It says you deposit $2,500 in an account, so I'm just going to underline this, that pays 6.5 annual interest. Find the balance after 5 years if the interest is compounded monthly. So remember, anytime it uses that word compounded, you are going to be using this equation over here. And it says compounded monthly, so we know we're going to use a 12 in the N spot. Okay, so we're doing this equation right here. So we start out with the initial, which is 2,500. You have 1 plus your rate. Now your rate is 6.5, so you move that decimal over twice. 1, 2, which is 0.065. Over N. It said monthly. We just looked up there. That meant it was 12. And then it is raised to the N, which again is 12. And your years are 5. Okay? So there it is right there. Now, for me, I just kind of type it all in. But do you see that little fraction, this little fraction right here? I make sure I put that in an additional parentheses. Okay, so let me just kind of scoot my calculator over here so you can see me typing it in. Okay, so I'll do the 2,500. I'll do 1 plus. Now, when we have that little fraction, I like to put mine in a parenthesis because it makes me nervous that the calculator is not going to do PEMDAS. So I make sure I put it in parentheses, use my little caret button, and 12 times 5. Enter. So there's your answer right there. Okay, so let me switch back here. And my answer is, and now this is in money, so we have 3,457.04. So make sure when you do money, you're rounding to the cents, okay? All right, so now it says, now find the balance under the same circumstances except for the interest is compounded continuously. So if you look down here, this is the one that I just didn't explain, okay? We haven't really done it that much. P is your initial amount. E, remember that's a button in your calculator. R is your rate, and T is your time. So P is the initial amount, which is 2,500. You have an E. And then your rate is 0.065, and your time is 5 years. Okay, so it's the same type of thing. It's just different equations. So initial E, here's our rate, here's our time. So I'm just going to switch over using my calculator. All right, so we're going to put 2,500. Remember, E is in there. It is second ln, and then 0.065 times 5. So that's what we get right there. Okay, so let me just switch over here. And again, it's in money, 3,460.08. Okay. All right, the next one. You purchase the car for $7,000 and the value depreciates. So depreciates 8%. Write in the exponential decay model for the value V of the car. Okay, so we know that we are using this equation right now because it says exponential decay. So we do initial amount and then rate and then time. So my initial amount is 7,000. 1 minus, my rate is 8%, but remember we moved the decimal over twice. 1, 2. So you have 0.08. Raised to the t. What was the t? I already forgot. Oh, it doesn't tell you, so we put a t here. Okay? Now in B, it's going to tell you what actually t is. So instead of putting that t, we're going to now plug in the 4. So we'll have 7,000, 1 minus 0.08 to the 4th. Okay? So I'm just going to bring my calculator over here so you can see it. And I'm going to do 7,000, 1 minus 0.08, close that parentheses, to the 4th. And there it is. Again, it is money, so we want to make sure that we write it as money. So 5,014.75. All right, let's flip it over. These are my favorite ones on the back with the swoop and stuff because I feel like they're easy and we should love it. Okay, describe the transformation. So I'm just going to come over here so that I can kind of look at it. So here it is right here. Let's start with the 1/2. So that is a vertical shrink. Now remember, it is a shrink because it's less than 1. So a vertical shrink of 1/2. The +1 in there is going to be left 1. And then the -4 is going to be down 4. Okay? All right, now my favorite, swooping time. So remember, when you swoop, you always start with the base. So the 4 is the base. I like to kind of just circle mine. And then you're going to swoop it around. Okay? So remember, you start with the base. And you follow your swoop. So the swoop touches the 2, and then it goes for the 16. Okay? So again, circle your base, which is that little 8, and swoop it around. So 8 comes first, then the swoop touches the 3, and then it goes to the 5/12. Okay? Last one over there, number 9. Circle that base, swoop it around. So it's touching the 5 first, then it goes to the -2, and then it goes to the 1/25. All right, so now let's do some logs. We're going to now rewrite in logs. So remember, when you do it, you're going to swoop it around, okay? And you'll always start with the base. So the base here is 10. Swoop it around. Okay, so this is log base 10 of 100 equals 2. Okay, so the base little 10 went first, then it touched the 100, and then it touched the 2. Remember, if we're base 10, we do not have to write this 10 if we don't want to, okay? It's assumed that it's there. All right, next one. I'm going to circle that 10, and I'm going to swoop it around, okay? So log, and then the 10. It touches the y next, and then it goes for the x. Okay? Now, for your evaluate ones, you're still going to swoop, but before you swoop, you're going to set it equal to a variable. So I'm going to set it equal to a x. Now, this one is kind of different, okay? Only because it tries to trick you a smidge. I'm trying to think of how I want to show this, okay? Because see how you can't see the little exponent, the little base? That's a base of 10 when you can't see it. So I'm going to go ahead and circle it. I'm going to swoop it around. So this says 10 to the x is equal to 10 to the 5. Well, what does x equal? If you want them to be the same, right? X is going to have to equal the 5. Okay, that one was a little tricky because it didn't put that 10 down there maybe. I don't know what you guys are going to think is a little trickstery. All right, again, I'm going to set it equal to a variable. Now, it's got an invisible 10 right here, so I'm going to go ahead and put it, there's my base, a visible 10, and swoop it around. So I'll have 10 to the x is equal to 1 over 100,000. Now, here it is, guys. Don't be freaked out about it because it is a fraction, okay? What it's going to happen is think about it as 10 to the what is 100,000. That's 10 to the 5th. But because it's a fraction, it's actually going to be a negative 5 because that produces the fraction, the negative, okay? What you can do also is you can just count the zeros. See how it has 5 zeros? That's how we got 5 here, okay? All right, again, I'm going to set it to the variable. I'm going to circle the base, which is a 5 this time, and swoop it around. So 5 to the x equals 25. Well, 5 to the what is 25? Yeah, 2. 5 squared is 25. All right, so those are those. Now let's go. What we're going to do first is we're going to rewrite these as a single logarithm. So really what we're going to do is we're going to squish it. We're going to write it with just one log. So first thing I'm going to do is you see this little 2 right here? I'm going to back him up because the 2 is actually the exponent. So I'm going to back him up first. So 3 to the 2. Now, I've got a plus sign between these two. So when I have a plus sign, what is that actually? Multiplication. So I'm going to have a log and I'm going to multiply 3 squared times 1/9. Okay, so don't put the log in your calculator. Just put in your calculator 3 squared times 1/9. And you're going to get log 1. Okay, now it does say evaluate, so I'm going to set it equal to an x. My base is right here. He's an invisible 10, so I'm going to just put the 10 there. And then swoop it around. So this says 10 to the x equals 1. Well, anything to the 0 power is 1. So you could have 20 to the 0, that's still 1. 15 to the 0, that's still 1. 16 to the 0, that's still 1. Okay, so anything to the 0 power is 1. All right, let's try it again. I'm going to squish this one. You see this 3 right here? He's an exponent, so I'm just going to bring him back first. So I'm going to have log of 80 minus log 2 to the 3rd. So I just brought him back first. Now I'm going to squish him. What does it mean when you're subtraction? When you squish them, what operation is it? Good, it's division. So I'll have 80 over 2 to the 3rd. Now, I need to simplify this before I evaluate. So in my calculator, again, don't put the log in your calculator. Just do 80 divided by 2 to the 3rd, which is 10. So I have a log of 10. So again, you have to simplify. Then set it equal to x and swoop it. So right here, there's an invisible 10. So when I swoop it, okay, let me move my screen over. It's going to be 10 to the x equals 10. So what is x going to be? What is the exponent that is going to give you a 10? Right, 10 to the first is 10. So x has got to be 1. Okay? Now what we're going to do is we're going to expand these next two. I like to look at it like this. However many variables or terms you have will be how many logs there are. Okay, so see you have an x and an y squared. That means that there's going to be 2 logs. Now, they are multiplied right now. So when I expand them, what's the opposite of multiplication? Yes, addition. So I'm going to go ahead and expand them by using addition. Okay, so I just expanded by using addition. Now you see this little squared right here? I need to bring him to the front and then he's done. So log x plus 2 log y. So there you are. You just expanded it. All right, let's go one more time and then we are done. So look at here. See how many terms it has. It has an x, it has a y, and it has a z. So that's 3 things. So meaning you should have 3 logs when you are finished. Okay, so let's start at the top. The x and the y are being multiplied. So we know the opposite of multiplication is addition. Okay, so I've got that started out. Then the z is on the bottom. So meaning it's division. So we know we're going to minus a log of z. All right, guys, that's it. Make sure you look over this a bunch of times. The quiz on Friday will be summative, so you're going to need to really understand it. Remember, we all have office hours, so check in if you need help.